Okay, 5.4, dosages and concentrations. So an important application of volume, which we just studied in 5.3, involves dosage problems for medication. Doctors, nurses, and vets are faced with a vast array of medications in varying concentrations, such as milligrams per milliliter, units per cubic centimeter, percentage, etc., and dosage amounts, milligrams per kilogram, units per pound, grams per pound. In order for us to make intelligent health decisions, we all need to understand this terminology and double check any medications that we have to take for our family or family member or pet or livestock. So the definition of a concentration is a solution, is a ratio of one substance mixed with another substance. I mean, in a very simple level, you can think of that as salt water. You have water, you pour in a certain amount of salt, and you mix it up, and you have a solution. Typically, it's weight to volume. In other words, a pound of salt to a gallon of water. That would be weight to volume. But it could also be weight to weight. Dosage of a given medicine is the ratio of the amount of the medicine to the weight of the patient. The most straightforward problems don't involve concentrations or weight of patients. So here's example 5.16. Administer this antibiotic, amoxicillin, 0.2 grams every 8 hours. Amoxicillin is available in 125 milligram tablets. How many tablets need to be given for each dose? All right, so here we have grams. That's what the dosage calls for. And we have milligrams. That's what the tablet contains. How many tablets? Well, in 8 hours, you're going to have 3. That's just, or you want it each dose. Okay, so in this problem, the 8 hours is not going to impact our calculation because we just want to know what dose is given every 8 hours. The medication is available in tablet form, 125 milligrams each, no liquid or concentration is involved. Therefore, we just convert the dosage, 20.25 grams, into milligrams. And there's 1,000 milligrams per 1 gram, so this is just using dimensional analysis. 0.25 grams, the grams cancel, 0.25 times 1,000 is 200 milligrams. Each tablet is 125 milligrams, so you need 250, so you get 2 tablets. Hope that makes sense. Okay, so let's do this one. Potassium chloride is available as 3 million micrograms per tablet. Potassium chloride, it's called KDOR, is ordered 0.021 kilograms is ordered. How many tablets would the nurse administer? So you got 1 gram is 1 million micrograms. And we need, the order is in kilograms. So first we're going to convert kilograms to grams, and then grams to micrograms. So our first conversion, we should know, right? 1,000 grams equals 1 kilogram. Now I can do this with a proportion, or I could do it with dimensional analysis. Let's use dimensional analysis. So think about what I'm going to do. You might hit pause. I'm going to start with this. What am I going to multiply it by? And if you guess that, you would be correct. In this case, the kilograms cancel. And multiplying this by 1,000, you just move the decimal 3 places, so I'm going to get 21 grams. Now I'm going to take the 21 grams and I'm going to convert it into micrograms. So what am I going to multiply the 21 grams by using dimensional analysis? Give it some thought, hit pause and think about it. And if you guess that, you're correct. The grams are going to cancel and I'm going to get 21 times a million, which is 21 million. Or move the decimal 6 places. So each tablet is 3 million micrograms, and that's what I got here. Micrograms. And I have 21 million that I need. So it's going to be, hopefully you see this, it's 21 million micrograms divided by 3 million micrograms, and I'm going to get 7 tablets. And hopefully that makes sense. So a more challenging problem would involve dosage as a rate per kilograms of body weight. In other words, the dosage rate is going to change depending upon how much a person weighs. So we're going to give Celor, which is another antibiotic, at 45 milligrams per kilogram per day in 4 separate doses for a patient weighing 52 pounds. Now, what is really important to understand is this. They don't do this, but maybe they should. Put a 1 there. So what it means, you want 45 milligrams of the medicine for every 1 kilogram the patient weighs. So if the patient weighs 2 kilograms, you would get 90 milligrams. Obviously, most patients weigh more than 2 kilograms. And that's per day. So in 4 separate doses. So whatever the amount of medicine you're going to give the person, you're going to divide it by 4 in 2 separate doses. So Celor is available in 150 milligram tablets. How many tablets should be given per dose? Well, the first thing we have to do is determine how much of the medicine to give using the dosage of 45 milligrams of medicine for every 1 kilogram of body weight. We'll do that by dimensional analysis, converting pounds to kilograms. So there's the conversion factor right here. Dimensional analysis, the pounds cancel. It's basically 52 divided by 2.2, and I get that many kilograms. So a 52-pound person weighs 23.64 kilograms. Now, I'm going to use dimensional analysis again, take the kilograms and multiply it by 45 milligrams for every 1 kilogram. Kilograms cancel, multiply 23 times 45, and I get that many milligrams. And that's the daily dosage, because that's what it says here. So we are told this is going to be administered in separate doses. We divide by 4. Why do we divide by 4? Because there's 6 hours in a day, 4 separate dosages. So we divide by 4 to get 266.5 milligrams for each dose. So there's the milligrams for each dose, divided by the number of milligrams in each tablet, and I get 1.78 tablets. Now hopefully you realize that this last answer, 1.78 tablets, is problematic for a nurse. How are you going to cut a tablet to exactly get 0.78 of 1 tablet? This is the reason they mix powdered medicine, measured in mass and grams, measured in grams by weight, with a saline solution, measured in volume. This is what I was talking about before. Weight per volume. So they're going to make a solution so they can get a more accurate dosing. And we'll start here in the next slide.